Perseverance was sent to Jezero crater because scientists were confident it was an ancient lake bed. What the rover found in the rocks completely rewrote that confidence and raised a possibility nobody had planned for. The crater floor wasn't what the models predicted. And the explanation that fits the data best is one that makes the question of Martian life significantly more complicated and more interesting at the same time. Jezero crater is a 45-kilometer-wide impact basin in Mars's Isidis Planitia region. Before Perseverance landed there on February 18, 2021, orbital imagery had already identified features that strongly suggested an ancient lake, a clear inlet channel where a river appeared to have flowed into the crater, a delta deposit of sedimentary material at the western rim where that river slowed and dropped its sediment load, and a possible outlet channel on the opposite side. The scientific case for Jezero as an ancient lake was strong before the rover touched down. The surprise began when Perseverance drove across the crater floor and analyzed the rocks directly. The floor of Jezero is not primarily made of sedimentary rock, the kind formed from layers of settled material in a lake environment. Instead, Perseverance's instruments revealed that the crater floor is dominated by igneous rock formed from the cooling of magma. Specifically, the rover's Pixel instrument, the planetary instrument for X-ray lithochemistry, and the Raman spectrometer on Sherlock identified olivine and pyroxene minerals consistent with solidified magma. Some of the rocks show features consistent with slow cooling of a magma body beneath the surface. This was not the expected result. Scientists had anticipated sedimentary rocks at the crater floor, lake-bottom deposits that would be ideal for trapping and preserving biosignatures, the chemical or structural evidence of ancient microbial life. Finding igneous rock instead raised immediate questions. But igneous rock is not the end of the story for habitability. It is a complication that actually opens a different window. Several of the igneous rocks Perseverance examined show clear evidence of alteration by water. The minerals have been chemically modified in ways that require liquid-water interaction, a process called aqueous alteration. Some rocks contain carbonate minerals and perchlorate salts deposited in fractures and veins, which are signatures of water moving through the rock after it solidified. This means the igneous basement of Jezero crater was fractured and permeated by water at some point in Mars's past, even if the surface was not consistently a calm lake. In 2022, Perseverance reached the ancient river delta at the western rim of Jezero, and there the sedimentary rocks scientists had hoped to find on the crater floor appeared in abundance. The delta exposed layers of fine-grained sediment deposited in quiet water, exactly the kind of environment that on Earth is associated with the preservation of organic material and microbial signatures. Perseverance collected samples from the delta that are among the highest priority cores in the planned Mars sample return mission. In 2023, a study published in Science by the Perseverance science team reported the detection of organic molecules in Jezero crater rocks, specifically in the delta deposits. Organic molecules are carbon-based compounds and are not themselves evidence of life. They can form through non-biological chemistry, but their presence in the right geological context, associated with fine-grained sediment and aqueous alteration, is exactly the combination that biosignature hunters look for. The full picture emerging from Jezero is more complex than the pre-landing model. The crater floor records a history of volcanic activity and subsequent water interaction. The delta records a period of sustained water flow and deposition. The whole system was chemically active in water, over potentially long timescales, in ways that make the preservation of ancient biosignatures physically plausible. What the rover cannot yet determine from its instruments alone is whether any of the organic molecules it detected are biological in origin or purely abiotic. That determination requires the kind of laboratory analysis on Earth that only the Mars sample return mission can provide, bringing the actual rocks home for analysis with instruments far more capable than anything a rover can carry. The samples are cached. The question is still open. And the answer, when it comes, may be the most significant scientific finding in human history. Follow for more on what Perseverance is finding as it continues its mission. And tell me, if the Mars sample return mission brings those Jezero samples to Earth and organic molecules are confirmed, what level of evidence would it take for you to accept that Mars once had life?